Heating and cooling curves are interesting. So interesting things happen. If I start with water at minus 10 degrees and I add heat to it, the temperature goes up. Now, that shouldn't surprise anybody. If you add heat, the temperature goes up. But at 0 degrees, something funny happens. This is ice. At 0 degrees, the ice melts. And while it's melting, the temperature does not change. We continually add heat, but the heat doesn't change the temperature. Instead of making the molecules move faster, it's breaking up the interactions between the molecules. When all the ice is melted, and we continue to add heat, the temperature again rises until we get to 100 degrees. At 100 degrees, steam starts to form. And again, the temperature will level off. So this is liquid water. Here we have steam being formed. And when all the water is in a vapor state, then the temperature will continually to go up again. So here we've got a solid going to a liquid, and here we have our liquid going to a gas. Okay? So the important things to note are that as you add heat energy, the temperature will increase until you get to where this transition occurs, and then the energy no longer increases the temperature, but it instead melts the solid. When all the solid is melted, then the temperature will increase until it reaches the temperature at which the liquid can change to a gas. When the liquid changes to a gas, the temperature does not increase because the energy is going into breaking the molecules apart from one another. When all of the substance is a gas, then the temperature will increase again. There are different equations used for the parts where the temperature changes. Heat is equal to the mass times the specific heat times the change in temperature. Where there is no temperature change, heat is equal to the mass times the heat of vaporization if it's a liquid gas transition, or heat is equal to the mass times the heat the heat of fusion. Sorry for my writing there. So we've got heat is equal to mass times the heat of vaporization, or heat is equal to mass times the heat of fusion. This is for a solid liquid, and this is for a liquid gas. Okay? So that's what you need to know about these heating and cooling curves.